we're going to look at complex numbers. And what complex numbers are is a combination of real and imaginary numbers. So if we think of complex numbers as some sort of real number plus some sort of imaginary number. Okay, so remember, imaginary is not pretend. Imaginary is just something simply that we have a square root of a negative number. So the way we're going to look at this is our real would be identified as A, as in some real number, plus some imaginary number, which we would think of as some number B times I. And let's remember that I is equal to the square root of -1. Okay? And the other thing that's important to remember is I squared is equal to this whole thing squared. So if we were to square it, we're just going to get -1. Okay? So that's very important to remember this definition right here. Okay. So let's look at an imaginary number. So imaginary number is part of the complex number field. So if I have the square root of -18, I have to be able to simplify this. There are two rules. One, you can't have a negative under the square root. Okay, just not allowed. Okay, so here we have a negative. So let's just see what's going on here. We're going to think about this over here. So I have the square root of -18. Well, that is actually the same as the square root of -1 times the square root of 18. And I know by definition that the square root of -1 is I. So that means that this becomes I square root of 18. Okay? Instead of having to do all that math, I am simply going to take note that I have a negative under the radical, and I'm going to pull it outside the radical as an I. So now I have I square root of 18. Okay. So now I have a second rule, and the second rule is that I can't have a factor that is a perfect square under the square root. Not allowed. Okay, so what does that mean? Well, let's think about what are my perfect squares. So I'm just going to brainstorm a list of perfect squares over here. So my perfect squares are 1, 2 times 2 is 4, 3 times 3 is 9, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. Okay, so these here are my perfect squares. Okay, so that means that's another real important thing that I need to keep in mind. And granted, they keep going on forever. I'm just stopping at 100. So that means that I have to think of my factors of 18. So let's go ahead and let's use the calculator, and we're going to get our factors of 18. You could do this longhand, but since we know how to do this on the calculator and we're allowed to use a calculator, let's go ahead and take advantage of that. So I'm going to take 18 and I'm going to divide it by every number in the universe, x. to find the factors. So now I'm going to go to second table. And here we see in second table, oh nice, look, I have 9 and 2. 9 being my highest perfect square. Okay, I'm going to just scroll back here. I could have looked here. Here I have 2 and 9. It really doesn't matter which side the perfect square is. As soon as I find my largest perfect square, I'm golden. So that means that the square root of 18 is the same as the square root of 9 times the square root of 2, and I don't want to forget my I that's in front. I typically like to put my perfect square first because then it doesn't get too confusing. So the square root of 9 is 3. The square root of 2 is just the square root of 2. And my I is simply my I. So now these things here are all being multiplied together. Let me just point that out. It's all being multiplied together. I don't like saying I3 square root of 2. So by convention, I'm going to write this 3I square root of 2. So this means that the square root of negative 18 is exactly the same as 3I square root of 2. So now I have simplified an imaginary number which is part of the complex number field.